Hi everyone! In this video we're going to continue to learn how to sketch polynomials and make them a little bit more accurate than the last video. So what I want you all to do is to take the things you learn about zeros and end behavior, or intercepts and end behavior, and sketch as much of this as you can. I'm going to pause the video and come back with what I expect you to have. Okay, you should have got that the zeros are at 1 and 3. The leading term, if you multiply it all out, although I gave it to you down here, is 2x to the third, which means this is a cubic function, degree of 3. The end should go in opposite ways. Lead coefficient is 2, is positive, so it should go on the left, it should be down, on the right, it should be up, like a regular cubic function. The constant term is negative 18, which means the y-intercept is 0, negative 18, because that's where, when you plug in all the x's or zeros, you get your y-intercept. So I haven't actually sketched it yet, because I'm having the problem where if I want it to go through all these things, it might look something like, maybe we should try that again. It might look something like this, I don't know. Hey, wait a minute. If I wanted to go back up, it would have to cross again here, but there's no 0 there, which means doesn't the end behavior need to be down, down? And I get very confused. So that is the motivation for learning something new today, and that is called multiplicity. Let's use that word down here. So what multiplicity means is the amount of times a 0 is counted. And that comes up in the problem right here. So x to the first, there's only one of those because it's x minus 1 to the first. But x minus 3, there's actually 2 of those because it's x minus 3 times x minus 3. So really, I guess you can say I would have 2 zeros that are both at 3. And that is, I guess what we can write first is the fact that x equals 3, something special is going to happen. It's quote-unquote double counted. And then probably the more precise way to say that is the multiplicity is 2. Whereas this one, the multiplicity is just 1. So multiplicity tells us how many times that 0 is counted. And let's take a look at Desmos here to figure out how that affects a graph. So say we have a 0 at, let's see, x plus 1 would actually give us a 0 at minus 1, which you see right here. And c is the exponent. So if it's x plus 1 to the first, it looks just like this. Now, if that's the second, that means x plus 1 is counted 2 times, and it looks like this. Okay, now what if it's x plus 1 to the third? It looks like this, into the fourth, then to the fifth, sixth, seventh, eighth, which means x plus 1 is counted 8 times. Now, one thing you should be noticing is something you already know, and that's the end behavior is going from the same direction to the different direction, same, different, so on and so forth. But actually what we want to talk about is another thing that this does, and it specifically does it to the x-intercept. So take a look. What do you notice about the x-intercept here versus the x-intercept here versus the x-intercept here? Here. So one thing I hope you're noticing is that it looks different on the evens than it does on the odds. Okay, so that's what we want to look for here. And on all the odds, what's going to happen is that it's going to cross through the axis. So at 7, it crosses through. At 9, it crosses through. But on the evens, such as if I have x plus 1 counted 4 times, it's not going to cross through. It's just going to bounce, like a bounce point. Probably a better word that you know, hopefully from geometry, is that it's tangent to this point, which means it doesn't cross through. It's just tangent to the axis. Okay, so at 6, it's tangent to the axis. At 8, it's tangent, or you can say it's bouncing off and going back in the same direction. So anytime you have an odd multiplicity, it's going to cross through. Anytime you have an even multiplicity, it's going to be tangent or bounce. And you should write that on your note sheet somewhere. I'm not going to write it down, but you can. So when I have this 3 is being double counted, instead of crossing through with the 3, it's going to just bounce. And it can either bounce like this and go back in the same direction, or it can look like this. And the rest of the stuff you have will help you figure out what that looks like. So with that said, it's got to be down on this side, and it's got to go through the y-intercept. So now I can sketch this a little bit easier. So it's going to go through. It's going to cross at 1 because the multiplicity is odd. It's counted once. And then it's just going to bounce and go in the same direction at x equals 3 because the multiplicity is 2. And I'm going to write that down here. The multiplicity here is 2, which means that 0 is double counted. And here the multiplicity is 1, which is odd. And here the multiplicity is even, so it's going to bounce. Again, probably a more precise word would be, it would be tangent here. So now knowing zeros, y-intercepts, and behavior multiplicity, we can get an even more accurate sketch. And if you want to be even better than that, what I can do is start using some test points. So let's do that so we can make this even better. For this graph, I just made a guess at how high this goes. We can actually figure out what it's going to look like if I plug in, let's say, 2 to the function up here. So if I do that, I have y equal, right? This is like y, quote unquote. Y equals 2 times 2 minus 1. So plug it in 2 for those x's. And then 2 minus 3 squared. So to get what that point is, we're going to have 2 times 1 times negative 1 squared. Negative 1 squared is just 1. So it's really 2 times 1, which gives us the y-coordinate is 2. So at the x-coordinate of 2, my y-coordinate would also be 2. So the graph should actually come a little bit higher than what I drew it. And now we get a more accurate picture of what that's going to look like. And something like that. Okay, the more points you plug in, the more accurate you're going to be, but I just want to give you another strategy. So if I ask you to plot a specific amount of points, you know that you can plot as many as you want just by plugging in values. So I could plug in like -1 and figure out where it is down here, so on and so forth. Okay, so that's multiplicity. That's what's kind of new for this video here. To summarize that, to determine the multiplicity of a 0. So keyword, you're talking about multiplicity, you're talking about the x-intercepts. Okay, you look at the exponent of that 0. Okay, that's more precise, but really what you're looking at is how many times is the 0 show up? Is it counted? Okay, ask yourself that when you're asking multiplicity. So if the degree of the 0 is even, it's what we call, very not precisely, a bounce point. Okay, more precisely, we would say the graph is tangent at that 0. Specifically, it's tangent to the x-axis at that point. And if the degree of the 0 is odd, it's not going to be a bounce point, it's going to cross through. Okay, the x-axis to be specific, at that point. Or at that 0. I should say 0, not point. So that's multiplicity in a nutshell. Now you can get a more accurate picture, put all the things you've learned together, and you're going to be able to sketch any polynomial. Please come to class with any questions and have a great night.